Alright, today I'm going to talk to you all about what an Anova test is. So what is Anova and what does it measure? Anova stands for Analysis of Variance, and Anova is a test that compares 3 or more population means. There are 3 types of Anova tests. There's the Anova single factor, the Anova two-factor without replication, and the Anova two-factor with replication. The Anova single factor is going to be used when you want to compare the population means of 3 or more different groups. For example, you would use this test if you wanted to see if there was a significant difference between the average test scores of 3 different classes. The Anova two-factor without replication is going to be used when you want to compare multiple population means of the same population. For example, you would use this test if you wanted to see if there was a significant difference in the amount of sleep that the same group of individuals gets after trying 3 different sleeping medications. And finally, our Anova two-factor with replication is going to be used when you want to compare the population means of multiple populations that are doing more than one thing. For example, you would use this test if you wanted to test if there is a significant difference in the amount of sleep that multiple groups of individuals get after trying 3 different sleeping medications. In terms of hypotheses, the null hypothesis for every Anova test is going to be the same, and it's going to read that mean 1 is equal to mean 2 is equal to mean 3, etc., how many population means you're measuring, all of them will be the same. They will not be significantly different. And the alternative hypothesis for every Anova test will state that at least one mean will significantly differ from the other means. So how do we know whether or not to reject our null hypothesis? We are going to rely on the p-value for that, which I'm going to show you how to calculate in just a moment. So when the p-value is less than 0.05, we're going to reject our null hypothesis and accept our alternative hypothesis. And when the p-value is greater than 0.05, we're going to accept our null hypothesis and reject our alternative hypothesis. Alright, so I'm going to show you how we get our p-value from an Anova test on Google Sheets really quick. Alright, so this is just a quick sample set of data that I've created, and it is the test scores for different students in 3 different classes. So we're going to test if there's a significant difference between the average test score of each class. And just by eyeballing it, we can kind of see that class 1 did really good, class 2 did okay, and class 3 did not do very well. But we're still going to use our Anova test to see if the average test scores are significantly different. So I'm going to go up here to Add-ons and click on my Analysis Tool Pack and click Start. Now, if you do not have the Analysis Tool Pack installed on your Google Sheets account yet, I'll show you real quick how to do it. So you go to Add-ons, you're going to go down to Get Add-ons, and you are going to type in right here Analysis Tool Pack. It'll pop up really quick. You can click Install, and it installs in about a minute. It's very fast, very easy. Once you do have that installed, you're going to open it, and we can see right here we have all 3 of our Anova tests open. Now I'm going to be doing an Anova single factor test only today because I think it's the most applicable to our class and it's also the simplest to understand. So I'll be performing that for you all today. So we're going to click on Anova single factor. We're going to highlight our data for the input range, including our labels. And once we have that highlighted, we're just going to click input range and that put in our data. We're going to check labels are in the first row, and then to choose where we want our data to spit out, I'm just going to put it in F2, and once we have F2 highlighted, I'm just going to click output range real quick, and now we're ready to run it. So here are the results of our Anova test. As you can see, it does give us the average test score of each class and the amount of students in each class, and it also gives us our all-important p-value. So the p-value here is 0, and if we recall back to what that means, when the p-value is less than 0.05, we're going to reject our null hypothesis. So 0 is less than 0.05, so we're going to reject our null, and we're going to say that the average test scores between each class are significantly different. So what would it look like if the test scores were not significantly different? I have another sample set of data over here. I've already run the Anova test, I'll show you in a second. But if we just eyeball real quick, we can see all of the classes did pretty much the same on this test. Their averages are probably pretty similar. So we can go over to the results of our Anova test and look at our p-value and see that it's about 0.9. Now 0.9 is greater than 0.05, so that means we're going to have to accept our null hypothesis and state that there is not a significant difference between the average test scores of each class. Alright, that is the end of my video, but I am going to link a few articles and videos below when I post this because Anova is kind of complicated and kind of complex to understand, and I know it took me a few resources to understand it, so I'm going to put those resources that I used up for you all as well, and I hope you enjoyed the video.